Right, good morning class, or good afternoon or good evening, depending on when you watch this. This is Mr. Arocena, and on today's lesson we are going to talk about preferred redox reactions. We kind of already discussed a little bit of this in class when we were talking about the electrochemical cells that we created earlier, and we sort of covered this a little bit the other day when we were talking about how to go about calculating the voltage of an electrochemical cell. But today we'll talk more about how to when we start adding more and more substances to our cell container to see what preferred redox reaction occurs. All right, so quite often you will get cases where a cell, whether it be an electrochemical cell or a different type of cell, or just a container, contains a mixture of substances. And in cases like this, you will have multiple possible half reactions. So we already did this when we were writing out all the possible half reactions for the chemical cell that we had created earlier this week. So for example, here we have a cell. It contains a zinc, silver, and copper electrode. And we're going to figure out what reactions could possibly occur. So, I should make a note here that let's inappropriate solutions. So what do we mean by appropriate solutions is that the zinc electrode would have a zinc solution, the silver electrode would have a silver solution, and the copper electrode would have a copper solution. So in the zinc portion of the cell, you would have the following reactions. You'd have the oxidation of solid zinc. That'd be one possible reaction. You could have the reduction of zinc because it would be in a zinc solution. That'd be one other possible reaction. In the silver portion of the cell, you would have the oxidation of silver. Wait, not 2 plus. Silver doesn't have a 2 plus charge. Silver should only be 1 plus. Right, 1 plus 1 electron. Then you have the reduction of silver. And finally, the third possible set of reactions would be the solid copper being oxidized into copper ions. Yes. Minus, and then the copper ions getting reduced to become solid copper. Right. So those are all the possible reactions. Now, which ones would actually occur? Generally speaking, only one oxidation and only one reduction will occur. Okay, and we kind of already discussed this the other day, but we'll put it into words now. Okay, so generally speaking, we'll follow two rules when deciding what reactions should occur, and as a result, what the actual electrochemical cell will be. Okay, so for the reduction, we'll choose the highest reduction, or the reduction that generates the most electricity, or the reduction that has the strongest oxidizing agent. So the strongest oxidizing agent has the greater tendency to give away, or not give away. Oxidizing agents cause other things to get reduced. Yeah, sorry. The strongest oxidizing agent will be giving away the strongest thing that gives away electrons. Okay. And then similarly, we'll pick the strongest reducing agent. So the reducing agent forces other things to get reduced. So it's the thing that gives the most, the agent that has the greatest tendency to give away electrons. And the strongest oxidizing agent causes other things to get oxidized, so strongest oxidizing agent is the thing that has the greatest ability to accept electrons. And these you can just reference the table. So just use table to determine this. Oops. So we'll use the table to determine. Use the table to determine the strongest oxidizing agent, and similarly use the table to determine strongest reducing agents. And if you remember from earlier in this unit, the strongest oxidizing agents tend to be on the upper left, and the strongest reducing agents tend to be on the lower right. Okay. So if I go back to here in this example, let's see, this is an oxidation, this is a reduction, this is an oxidation, that's a reduction, this is an oxidation, that's a reduction. So of these oxidation reactions, the one or the strongest reducing agent, so the strongest oxidizing reaction, I believe is this one. This one is the reaction. This will be the predominant oxidation reaction because the zinc happens to be the strongest reducing agent. The reduction reaction that occurs the most, that will occur the most, I believe, will be this one, because I think this one is hot, or the silver ion is a stronger oxidizing agent than the copper 2+ ion. So this will be the predominant reduction reaction. So in this particular cell, the only reactions that will occur will be this one and this one, until a point you get where you either run out of solid zinc or you run out of silver ions, or you get to a point where these reach an equilibrium and no net movement of electrons. When that happens, then then the other reactions can take over or can start occurring, because the main redox reaction will have stopped, so that it leaves room for the others to come in and do their thing. All right, let's go through another example. So let's suppose we have an iron strip, and we place that in a mixture of bromine and iodine. So no, it's not bromine ions, not iodine ions. And we're going to say, okay, so what reactions would occur in a situation like this? Okay. Well, like before, we're going to list all the possible half reactions, and then we'll reference a table to find what is the strongest reducing agent and what is the strongest oxidizing agent. Okay. All right, so let's just... And yes, like I mentioned here, using the table helps. Okay, so this is probably the longest and most tedious portion of this, is just listing all the possible half reactions. Right. All right, let's move everything up. List all the reactions possible. So we have an iron strip, so a solid piece of iron. This, I believe, only turns into the following. Okay. Now, iron does have the ability to turn into iron 3+, but not directly from solid iron. Then you've got bromine. Bromine, I believe, will do the following. And then iodine will do the same thing. All right, so now you just get to decide, okay, what is the strongest reducing agent? What is the strongest oxidizing agent? The strongest oxidizing agent is, well, it's the strongest reducing agent's easy because this is the only oxidation reaction possible. So this has to be it, okay? So this is the only oxidation reaction available amongst the three half reactions we have. That's the only oxidation reaction available. So this has to be the oxidation reaction. Okay, now we just decide, okay, which one of these is a stronger oxidation agent? Is it the bromine or the iodine? And for that, we'll just reference our table. So let's, I have a digital table. Okay, fire up my data booklet. scroll down, and if you notice, let's see, there's chlorine. Chlorine's pretty high here. There's bromine. Bromine is also equally high. So there's bromine. Whoops. There. Let's see. I do not. Oh wait. Highlighter. Oh, I can't highlight. Anyways, whatever. There's bromine. Bromine's there. Bromine is here. Iodine is down here. So bromine is a stronger oxidizing agent. So going back to our notes here, since bromine is the stronger oxidizing agent, this will be my reduction. Where's my reduction? Right, there we go. So now we've determined that these will be the oxidation and reduction pair for this redox reaction. Now, if at some point we run out of bromine, then the iodine reaction can fill in after the fact. Okay. So this will only occur after the bromine runs out. There we go. Because the bromine is the stronger oxidizing agent, so it's going to force iron to give it its electrons. Iodine isn't as strong of an oxidizing agent, so it has to wait its turn. All right. Okay, so here's another example. It's a little more complicated. Okay. So let's suppose we put an iron nail, but we're going to wrap it with a piece of copper and a piece of magnesium. And then we're going to stick it in a solution containing copper sulfate and chlorine. Okay. This is actually a kind of a real thing. A lot of applications involving bare metal will have bare metal wrapped around other bare metal, and there is a purpose to that. You might be able to realize it once we go through this example, and if not, that's okay. We'll talk about it probably next week or later this week. Right, so same process. We're going to list all the half reactions possible, and then we'll find the strongest reducing agent and the strongest oxidizing agent. There we go. All right, so we have an iron nail. So we have a solid piece of iron. That's one possible oxidation. Minus, we have a piece of copper. Now, copper solid actually has two different two different oxidations, so you could list both. I believe copper solid has the ability to turn into copper 1+. Okay, and then magnesium, the next one, going to magnesium 2+ plus 2E-. So here we have like 4 possible oxidation reactions. All right, and then we have the following. We have a copper sulfate solution and a chlorine solution. So the copper sulfate solution provides us with copper ions. So this is one possible reduction. Okay, the chlorine gas gives us another possible reduction. So, and the SO4 actually provides us with another oxidation reaction, which is, I'm trying to remember now. Oh, let's look it up. There's a very top here. SO4 2- to S2O8 2-, and two of them. S2O8 2- plus 2 electrons. Wait, is that right? Yeah, that's right. There you go. All right, so we actually have quite a lot pick from. As far as the oxidations go, there's 1, 2, 3, 4, 5 different oxidation reactions. So we just look for the strongest one. I believe that will be the magnesium, because the sulfate one's a pretty weak reducing agent, so we can generally ignore sulfate as an oxidation reaction. So we'll scroll down and we'll look for iron. Well, there's copper going to copper 1. Okay, copper going to copper 2 is more likely because that version of copper is a stronger reducing agent. So we'll cross that. I still haven't found iron though. There's iron, so it looks like iron is the candidate, but then we'll look for magnesium next. Scroll down. There's magnesium. Magnesium is way down, so magnesium is a very strong reducing agent. Yeah, strong reducing agent, because reducing agents get oxidized. All right, so this will be our oxidation reaction. There. Now, from our list of possible reduction reactions, which is a stronger oxidizing agent, let's take a look. Back, I think that was easy though, because I mentioned it a few times before. Oh, I'm talking about fluorine. Fluorine's really strong oxidizing agent. So that's not fluorine, but there's chlorine, which is pretty high up. And then the copper 2+ we saw earlier down here, there's copper 2+. So it's not copper 2+, it'll be the chlorine. So chlorine is a strong oxidizing agent. Ta-da, there we go. So there's my 2 reactions. So this is my oxidation here. And my reduction is over here. There. Okay. Alright, so again, the tedious part about this particular problem is just trying to write out all the possible reactions and then figuring out from there is not too difficult, I don't think. As long as you have your table with you. If you don't have your table, it's a little, well, unless you've memorized parts of it, it's hard to figure out without the table. Alright. Now, there are such things as spectator ions when we're talking about preferred reactions, and these are ions that, so if they can have the ability to be reduced or oxidized, but generally in the presence of a stronger oxidizing agent or a stronger reducing agent, these ions choose not to. Okay. So if there's an ion that is either a stronger reducing agent or a stronger oxidizing agent, they will be the ones that will be preferentially oxidized or reduced. The other ions have to wait their turn. Okay. Generally speaking, the following are spectators, meaning that if these ions are present, they pretty much don't do anything. Okay. And one of the things that you'll notice is that these are very weak. They're very weak reducing or oxidizing agents. Okay. And part of the reason that we use salts with these ions is, again, because these ions are very weak reducing or oxidizing agents, they have a very low chance of interfering with the reaction. So if you remember the electrochemical cell we built earlier, we used a sodium chloride solution. So with sodium ions and chlorine ions, because they're such weak, let's see, this is a weak oxidizing agent, this is a weak reducing agent. Because they're so weak as oxidizing and reducing agents, they won't actually perform an oxidation or reduction reaction in our electrochemical cell until the other ions get used up. Okay, it would have been better if we used a sulfate anion instead of a chloride anion, because the sulfate's an even weaker reducing agent than the chlorine ion, but sulfate ions are hard to come by. Sodium chloride ions are very easy to come by, very common, but the sulfate ion not as common in household items at least. Okay. But there you go. So that's how you can determine what oxidizing reactions and what reducing reactions will occur. You simply look for the strongest reducing agent, strongest oxidizing agent, and then go from there. All right. Your assignment for today then is as follows. We will get to the other things. We're doing a little bit of backtracking, but that's okay. Given what we've done this week, this sequence of topics makes more sense. Okay, so there's your assignment for today. If you have any questions, you guys know how to contact me.